Okay, welcome to, this is the very last webinar of the whole course. So we're done today in terms of webinars. And it turns out it's going to be probably a shorter one than usual. I put in less material in this last piece because basically you get a project due and you got to spend time doing that. And you may have other classes where you could have finals. So I try to lighten up in the very last week. And so far, people don't usually complain about that. So let me share my desktop so that we can talk about what we're doing today. Okay, so the plan today is I will answer any questions you might have. And then we're getting into the very last statistical test of this course. It does not mean that's the last statistical test there is. There's hundreds of more, but it's the last one that we do in our class. And the statistical test is called ANOVA. It's done for something that we haven't learned how to do yet. So it's a good one to do. So we have already learned how to, say, compare two means. We've learned how to compare two proportions. We've even looked at many proportions using chi-square. So we've done all kinds of stuff. But we haven't learned how to deal with more than two means. So a lot of times you want to say, well, not just is there a difference in these two things, but maybe is everything the same? Like maybe the average age of marriage is the same in every state in America. I actually have no idea, but you'd want to do a statistical test to find out. You can't do it with just two things because there's 50 states in America. So that doesn't work. So you use something called ANOVA. And that's what we're going to be talking about. I'm going to give you a kind of a little warning though. You're going to feel like you understand it at the end of this webinar, but you won't. You just think you understand it. So I want to give you a heads up on that. So be careful because there's a lot of depth in here that we don't go over, because we can only do so much in an elementary stats class. But ANOVA is used a lot, just all over the place it's used. And we're only doing one type of ANOVA. There's many types of ANOVA, and we'll do one type of it. Because again, it's just like an intro to ANOVA. So last thing to do. We'll talk about the requirements that you need in order to conduct an ANOVA test. So remember that to conduct a hypothesis test for two means, for example, you need to make sure that either your sample size was greater than 30 or your population distributions were both normal. Do you remember that? So with ANOVA, we're going to have a lot more things. Okay. And then one requirement is the same requirement of everything. What's the requirement to do statistics for everything we've done in class, for every hypothesis test? It's a biggie. And as we talked about the first week of class. Thoughts?
Oh, you have to have a representative sample?
Yeah, you have to have a representative sample. If you have a biased sample, then you should just not do statistics. Okay, that's just bad. So that of course will be part of ANOVA, but there's going to be some others too that you have to have. So the representative sample is definitely going to be one of them, and there'll be others, things you need. Some we won't even understand how to figure out if it's true. And then we'll finish off talking about project 2. Project 2 is due on Sunday. And just to remind you, by 8 in the morning on Thursday, if you haven't already sent in your draft, then that's your last chance. So a day and a half or day and 2/3 or so from now is when you have to have it. I guess 5, 6. And that will be it. That's what we're going to talk about, and that'll be the whole course. So we'll be done. And let me ask you, are there any questions about anything?
We talk about project 2 at the end, right?
Yeah, probably project 2 questions should be at the end, because that we have I put in a big piece for project 2. Because ANOVA, I promise, won't take that long. Because it's just one little hypothesis test. It's an important one, but it's not that detailed. Nothing too intense. I don't think I've ever had a student complain about how hard ANOVA was. That's a good thing. But this week the hard part is your project. Okay, any other questions? Okay, just a note about the calendar, because this is important. So this week we're doing ANOVA. You'll have a chapter 13 homework set due, just like you have every Sunday. You'll also have you have a requirement, you have a discussion post due and replies, but this is different than any of the ones we've done. So let's just put it this way. You'll smile when you see it because it's the easiest one there is in the whole class. Okay, it doesn't even involve statistics, okay, or hardly. So you'll see when you get there, but please do not wait. If you get less than 10 out of 10 on it, you're asleep. That's all I can tell you. It just means that you didn't do it on time. So make sure by Thursday you do your initial post, and then you reply to some other people. This is one of those you can reply to multiple people if you want. That's fine, and encouraged. And again, there's nothing difficult about it, I promise. But if you don't do it, you don't get points. So make sure you do it. So it's an easy one. So you'll have that to do. You'll have the project that will be due on Sunday night. Okay, and I strongly recommend do not wait until Sunday at 11 o'clock p.m. to try to post it, because that's when things go wrong and I'm asleep, so I can't even help you. So what I recommend is, if you can, get it done by Saturday earlier. So, because there's no real difference in Saturday or Sunday, just get it done, so that if something goes wrong, you have time to deal with it. So that's a big suggestion. And then a week from Wednesday is your last piece of the entire course. And that is the what I call the final exam, but it's an exam like all the rest of them, and it's not worth any more points than any of the other exams, just a note. But because all the exams build up on each other, as in, the first exam was just the first couple chapters, the second was the first 4 chapters, and the last exam you took was the first 12 chapters. So this exam will be all 13 chapters, but it won't be much different than what you've seen already. And it's not any more points either. So I don't do a high stakes final exam, just let you know that. So your final exam, it has to be done by Wednesday. It is the one thing that there are absolutely no extensions for dates, because after that, the course is over. And I turn in the grades and it's too late to do more because the grades are already turned in. So make sure that, if you're gonna have trouble on Wednesday getting work done, do it on Tuesday. That's my strong suggestion. Okay. And by the way, if you have a question, you can unmute yourself. You can also put in the chat box, whatever you want.
Hi. So I was wondering, I am graduating from Santa Monica Community College, actually. Well, I had the ceremony and stuff.
Oh, congratulations.
But they need my transcript as soon as possible. And I was wondering what date final grades will be submitted and on the transcript so I can get them sent there.
That's a good question. So I'll let you know, and hopefully you figured this out already since you've been in my class long enough. I'm not a procrastinator. Have you figured that out? I don't wait a long time to grade things. I'll have everything graded by Thursday. I'll have your grades submitted by Thursday. But what happens, here's the bad news. I submit them to the college and then it's bureaucracy.
Yeah, that was kind of what because I know that you grade things quickly.
Yeah, so I'll have your grades submitted on Thursday. I can't tell you what, exact, well, it'll be 8 a.m. or 10 a.m. or whatever, but I'll have your grades submitted by Thursday. What I don't know is how long it will take the college to process your grades. You know what I mean? I do my part, and I really don't take a long time. So that one, you might need to talk to admissions and records.
Yeah, no problem.
And you might want to wait until Thursday afternoon. And that way my grades will have been submitted and you can say, and you can even email, have the, maybe in Thursday at noon or something, have they been submitted or something like that. And I'll almost certainly say yes, unless we have some like disaster and I lose internet or something, but that almost never happens. And then once I've submitted them, then you can ask them how long it will take before they're on your transcripts. Does that make sense?
Yes, perfect. Thank you so much.
Yeah, and I'm sorry if I don't have more information than that, because I don't know. One thing I'm not is I'm not a student. So I don't see my transcripts because I have been a student here because I took kayaking. That was a fun class. But I didn't even look at my transcripts or grades for my kayaking class I took for fun. So I have no idea how long it actually takes for grades to be processed through the system, if you know what I mean on that.
Right.
But I
No
will have it.
problem.
Yeah. So that's my suggestion. It's possible it'll be 2 weeks from today, because that's when I'm required to return. I'm required to submit grades 2 weeks from today, by 2 weeks from today. But I always submit them a lot earlier.
Okay, thank you so much.
Okay, good question though. Good question. Other questions? Other questions?
I have a question about the test.
Uh-huh.
There was one question where it was like, tell us why the y-intercept for the GPA at 1.4 something is not relevant.
Mhm.
And I don't think I understood it.
Or tell it wasn't why it's not relevant. Is it relevant? And if it is relevant, explain what it represents, right? It's more like
Not
that.
how it's worded.
In
It
the
said,
you mean the
why is
written
it
part of the test?
not?
The written part of the test? Yeah, the written part, that's what I asked.
Yeah, go back
If
and
it's
look at it.
relevant, if it's not relevant, say it's not relevant. And if it is relevant, then you need to. Yeah, that's how it's
I'm
worded.
telling you, you gotta go back and look at it.
Yeah. So the idea for the GPA was like
I get it. No, I get that it's relevant, but the way it was worded, it says, why is it not relevant? And I just couldn't figure it out.
I
So
think it
I'm
said,
telling
if
you
it's
that I
not
think it's
relevant,
worded wrong.
explain why it's not relevant. And because it was like 2 or 3
I
sentences.
could be wrong.
Yeah. Yeah.
Okay.
Yeah, because I wrote it. That's
Okay.
So right, and it
Okay.
was relevant because you can have a 1 point. You are allowed to have a 1.4 GPA.
Okay.
I mean, you don't want one, obviously, because that means you're a bad student. A DC student. A D student, and that's not good. But that would be relevant. It could happen. May not be relevant for your particular being because you're not a terrible student, but there are students like that. Okay. But yeah, that's what it was. It might have been hard for you. Maybe you were reading it wrong or something, or off reading it. But that's what it says. If it's not relevant, explain why it's not relevant. Otherwise, interpret. It was something at that point. Okay. Well, should we do ANOVA? It's our last piece of the whole class. So here's ANOVA. And ANOVA stands for analysis of variance. And I want to give you a warning. Those words are used because deep into the mathematics has a depth of analyzing variance, but you're never going to see it. So just because it's called analysis of variance does not mean your hypothesis, your H0 and H1 are going to be about variances. Nothing to do with that. So be a little careful about the language in calling it analysis of variance, because if I don't get to name these things, this is like, some statistics committee probably 100 years ago or something named it. And I don't think they did a good job, but we got to deal with it. So it's called analysis of variance, but it's not about looking at variances. It's about looking at means. And what it does is it tests to see if several means are equal or not. So as I mentioned a little while ago, when we've done hypothesis before with means, we had one mean and we had two means. And with two means, you compared the two, right? Are they not equal, greater than, less than, that kind of stuff. But if you have lots of means, then we're not going to be able to use a t-test because that only works for 1 or 2 means. Instead, we're going to have to use an analysis of variance test. So the first thing, and this is a little weird, and this is my suggestion because I didn't do this the first time I taught this like 25 years ago, and it was a disaster because no one could understand it. So I came up with something that people can understand. And that is H naught, right, as symbols. And that is the first mean equals the second mean equals the third mean. If there were 4 means, you'd say equals the fourth mean. If there were like 50 means, you would do dot, dot, dot equals mu sub 50. So if there's a whole lot, you can do dot, dot, dot. But if there's only like 3, 4, 5, you just list them all. Does that make sense? Okay, so H naught, you're used to the equal signs. So it means that all the means are the same, all the population means are the same, is what H naught says. It turns out that it may feel like saying the opposite of all the means are the same is that all the means are different, right? Is that correct? Okay, and the answer is not correct. So be really careful. So for example, if we looked at the, let's say, I don't know, how about the average income in America? Well, it's possible that, say, Kansas and Nebraska have the same income, but California has a higher income. So in that case, not all the means are the same, but they're not all different. So, but what we can say is that they're not all the same. And I think the easiest way of doing that is to do it and use some words instead of symbols. And that is at least 2 of the population's means differ from each other. Okay, typically you're going to do something that is relevant to whatever the survey is. So if you were doing, say, the mean income, you know, in America, and you're looking at by state, then you would say at least 2 of the population mean incomes by state, or states' incomes, differ from each other. So you'd put that income, word income in there. Okay, and probably the word state. Any questions on that idea? Any questions? Okay, so it allows us to handle more than 2 samples. And in your project, for example, you had 2 samples. Okay, but if you have more than 2, if you're comparing more than 2 things, we're able to use ANOVA. Any questions on the idea and the purpose of ANOVA? Okay, it turns out there's all kinds of things you need to be true in order to use ANOVA. So we have seen before when we did like a hypothesis test for a mean, then we had to make sure the sampling distribution was normal, or you can't do the hypothesis test. Do you remember that? Okay, and similarly, if you had a hypothesis test for 2 means, for the difference in 2 means, we had to assume that the sampling distribution, or know the sampling distribution, is normal for both of the mean, for both of the populations, or you can't do it. Okay, and if you have a sample size greater than 30, you were able to say, yep, we got it from the central limit theorem, we're good. But if you had a sample size of, say, 20, then the central limit theorem does not tell you have a normal distribution, so you have to somehow know it's normal. So if you're dealing with multiple means, it's the same idea. If you have, like, say, 10 means, you have to make sure the sampling distributions are all approximately normal. Okay, so it's just an extension of what we've already done when we did 2 means. Okay, this sounds like it's easy to say, but it's not easy to do. Because I like the example of, you know, like income in the United States. You know, is every state's population mean income the same? So you would have to conduct a study. What would the total sample size have to be?
31 at least?
A whole lot bigger.
Oh, wait.
Hmm?
Wait, why?
Because every state has to have at least 31.
you're saying total sample size. Okay.
Yeah, so the total sample size would have to be at least 31 times 50.
So over 1,500.
Yeah, that's already a huge sample size. So it actually, so as I said, it's easy to say that, oh, we just got to get over 31. But in practice, it's not always easy. It could be brutal. And that would be an example where it's brutal. Okay. All right, here's another one. And this is something we've never done before. But we have to have all the population standard deviations being equal, or at least approximately equal. And I will let you know, we have not learned how to know that's true or not. We haven't in our class, we have not had any statistical analysis to see if all the standard deviations are the same. Okay, we haven't even learned how to say if two are the same. Okay, but there are statistical tests for that, but that would be an upper division statistics class to kind of verify that the population standard deviations are equal. But it's actually pretty brutal to actually do the verification. So for our class, all I want you to know is that you need to know that they're true, that they're equal. Okay, you don't have to know how to find out if they're equal. You just have to know that that's something that has to be checked. Any questions on that? Okay, so the next one is the one I kind of started with, and that is you must have a simple random sampling or representative samples for all of the samples. And that we've had in everything we've done in the entire course. If you have bias, you can't run statistics. Does that make sense? So if you did the income in the United States, and let's say you went to a hospital and asked a bunch of doctors in Pennsylvania, and then you went to a, I don't know, construction yard and asked a bunch of workers in Michigan, that would be totally biased, right? Because you're like pushing up high for the doctors, right? So you got to make sure that you don't have any bias. Okay. We also have to have the samples must be independent. That's usually not a big deal. Okay, that's typically an easy one because it usually just happens. And if you go to the state and ask 31 people from New York and then ask 31 people from Texas, etc., they're usually gonna have nothing to do with each other, so they're independent. Any questions on that? Okay. And then finally, the samples were consistently taken. And this is something I don't think we've talked about. It's an important thing, and it's one of those where you just have to make sure you do things right. And I tell you, I think I mentioned my first job at a company when I was 10 years old or 11 years old. Do you remember what I did?
You're like telephone polling.
Yeah, I did surveys. So, and there were a lot of us doing surveys. Okay, it wasn't just me. It was this big room of people, polling people. And what we did is before we started, and I still remember it, even though I was just a child, before we started, the boss would get us all together and we'd have a meeting. And in that meeting, we would talk about how we are going to conduct the study and what is allowed, what's not allowed, how we're supposed to react to questions. And it was required that all of us use the same rules in the study, okay, and the same technique and the same processes. Okay, so that's the big thing with consistent taken, is that typically if you're going to do a study, like say in different areas, like states, I'm just giving the states as an example, you're not going to do it all yourself. It's too hard. You're going to hire people in every state, and you got to make sure that every person that you've hired is conducting the study in a similar fashion. Does that make sense? One thing that has to happen, which is a biggie, let's say you wanted to find out if you want to say on a scale of 1 to 10, 10 being I hate Biden, I say 1 being I hate Biden, 10 being he's the best president ever, how do you rate Biden? and you want to do it by state. Okay, and that's a typical thing they do, by the way. Okay, the study is done a lot. Okay, then what you have to make sure of, not just that the questions asked the same way, but the time needs to be the same too. So you can't have, say, those in New Mexico do it in February, and then 3 months later, those in Iowa do it. Because the problem is that that wouldn't be consistent, because how Biden is looked at changes from month to month.
But how about you being like 10 and other people being like 30?
Yeah, well, first thing, I'm not there to say whether it was done perfectly. I did a good job though. I didn't. There's never any big problems, actually. That's the good news. I was just a kid. They didn't even know I was a kid though. You know, I just literally, I followed the rules. I knew how to read, and I read the survey, and then I wrote down what they said, and you know, that's pretty much it. But the bigger issue that comes up a lot is timing. Is that you can't, especially if something has a good chance of changing over time, you got to make sure that each of the groups is surveyed at the same time. Okay, sometimes that's not even by month. Sometimes that could be morning, afternoon, evening, could be different because people's moods change, for example. So again, a lot of stuff happens, but it's something you have to note and you have to be careful of. Any questions on the requirements of ANOVA? Any questions? Okay, ANOVA, yeah, question?
So it cannot be like stratified. It can't be systemic. It's got to be simple random sampling.
No. So that's why I said, that's why parentheses, just no bias. That's the main thing.
Oh, okay. I got you.
So it's simple random sample is in theory the best. And then we've learned about stratified sampling, and that is not perfect, but it gets as close to a representative sample as sometimes you can practically get. Does that make sense?
Are you saying that simple random sampling is overall better than stratified
Oh, yeah.
sampling?
Yeah.
Oh, okay.
If you have a large sample size. Yeah. Simple random sampling has no bias. You know, and remember, that means that you really don't have voluntary response bias or any of that kind of stuff. Simple random sampling is you make sure that every single person you survey answers the question, you know, all that kind of stuff. And that is the best, but it's usually impossible. So that's why you do things that can approach simple random sampling, even though they're not perfect. And stratified is one of them. Okay, does that make sense? Okay, and again, perfection, don't just say if it's not perfect, then you shouldn't even do it, because it just perfect doesn't happen. We live in a world. And our world's not perfect. It's just not going to be. But what you don't want to be is like super biased. That's the main thing. Okay, so any questions on the requirements? All right, so I thought maybe I just popped in an example. Page 12. I just grabbed on our library a page I thought you should see. You know, it's really easy to find ANOVA because it's used all the time in literature. It's not used in your day-to-day life kind of thing, but in research, it's probably the biggest of all uses. Okay, this was evaluating well-being and worries of university students during COVID-19 pandemic. I thought that'd be relevant. Sorry if I depress you because we're all tired of COVID, but it's still around, and I have friends that have it. It's a bummer. Okay, I'm not going to read this whole thing because it would go on and on and on. But when you get to the results, I think that was this last one. They say one way ANOVA is applied according to residents' place that there are significant changes Okay, so they looked at different, kind of like state, like I was talking about, but they were looking at different places where people are living. And they wanted to see, is there a difference between all the different things that they're looking at, okay, with COVID. Okay, that's quantitative. This is only for quantitative, by the way. So it has to be number, survey questions, a number. And again, one way of making something that doesn't sound like a number is doing a scale of 1 to 10. Like my example with Biden, you can say on a scale of 1 to 10, you know, how afraid are you of getting COVID? Which is very different than saying, are you afraid of getting COVID? Do you see the difference? So you do scale of 1 to 10, and then you have a quantitative survey question. And then you could say, well, are students who live in the dorms versus students that live in apartments, maybe versus students that live in their home, in their families' homes. And is there a difference in how afraid people are, how afraid students are at COVID? Does that make sense? Okay. And you can ask all kinds of questions like that, and you can do ANOVA for each of them. And that's kind of what they did in this article. And they did one-way ANOVA. Notice, and you better be used to this by now, is they're comparing the p-value with 0.05, because that is the standard thing to use in any social science.
What is one-way ANOVA?
Good question. Remember at the beginning, I said there's different types of ANOVA, and we're only going to do one type, and the rest of them we're never going to touch, but they're upper division. So one-way ANOVA means that there is only one survey question, basically, asked of all the different groups. It's kind of like, remember we had a chi-squared test for independence? And there were 2 survey questions that were basically qualitative. So if you have 2 survey questions that are quantitative, then that would be then you could do a two-way ANOVA. But we're not doing that. That's not this class, so I'm not going to get into any details of that because there's a lot. And there's also a multi-way ANOVA, and I'm not getting into that at all. That's even harder. That might even be graduate level type things. So there's different types of ANOVA. And again, my warning at the beginning is that you're gonna know some of the basics of it, but not the depth, because this is an elementary stats class. But if you want to learn it, take another stat class. Go when you get into graduate school or upper division. That's definitely something you can do, and you can do multi-way ANOVA. Okay, but not today, because we can only do so much. So hopefully I didn't disappoint you by telling you I'm not doing it. But we can only do so much. Okay. So anyway, this is just an example. And by the way, they use all kinds of other tests. They use a Cresswell-Wallace test. That would be an upper division class. So there's all kinds of different tests that they used. And that's typical. I didn't just, I literally, this is the first article I grabbed and it had what I needed. And that's how most articles are if they are peer-reviewed articles. Most peer-reviewed articles use all kinds of different statistical tests. And ANOVA is really common, so I wasn't surprised when it was the first one I looked at. Okay. Any questions on just kind of looking at this? All right, so now let's do a kind of an example. Okay, and I want to remind you, do you remember what it means if I start with the word suppose?
It's not real.
Yeah, it means I totally made it up, but it could be done. Okay, I'll let you know this would not be one that you'd want to do because our sample sizes are way too small, right? We got, Black and other only have a sample size of 4. And hopefully at this point, you all know that sample size of 4 is not acceptable. But just for kind of going over what ANOVA is about, it works. Okay, even though you never do it in the real world. So suppose that a study was done to analyze the racial differences for the distance in miles that people live from the nearest public library. Okay, so for example, how many miles do you live from the nearest public library?
Less than 1.
Hmm?
Less than 1.
Less than one. Nice, nice. I live 2. Okay, so Braulio, how many miles do you live from the nearest public library?
Less than 2.
Less than 2. Okay, so maybe I made up numbers that were too big. I don't know. But you know, it might be an interesting study that people could do. Okay, it's definitely one you can do. And you know, one way you would do this is that you wouldn't ask how far are you from the nearest public library. You'd say, what's your address? And then you can go research it. Then you can go on Google and find out where the nearest library is and find out how far it is. Because most people, a lot of people don't know how far they are from the nearest public library. But the data from the study, oops, this should be, are shown below. So we have our white, our black, Hispanic, and other. Okay, so I want to mention one thing, and this is very much like when we had a test for 2 means. When we had independent data, it's fine if the sample sizes are not all the same. You don't have to have the same sample size. But it's not fine to only have a sample size of 4, but I didn't want to spend all day typing. Okay, so here's what we got. All right, so let's look at the following, and let me put this on its own page so I can keep it on the page. So the first question is, what assumptions must you make in order to perform the ANOVA test? So what assumptions do we have to make? See if you can remember.
You have to, sample is unbiased.
Okay, yeah, and by the way, the order that I put them up before, the order doesn't matter. They're assumptions, it's just a list. Okay, so unbiased sample.
Distribution is normal.
Yeah, and but let me correct your grammar. The distributions.
And all the standard deviations there.
Yeah, but let me type this out. So we got this one first. Distributions for all 4 races. And maybe distributions of library distances. For all 4 races are normal. And notice we have to make that assumption because if you look at these, none of these have a sample size over 30. It doesn't take long to see that, hopefully. Okay, so we got a 6, 4, 6, and 4. All those numbers are under 30. So let's say we end up surveying, you know, 40 whites, but only 10 blacks. Then you wouldn't need to make the assumption for the whites, but you would need to make the assumption for the blacks. Any questions on that? So again, it can get a little complicated. And it wants to have this. Okay, so we need to assume the standard deviations are all equal. Okay, so note, by the way, unbiased sampling, we have no idea if that happened or not, based on, you know, reading what's said. Distributions, they're normal. I doubt they're normal. So right away, you should worry a lot. I doubt that distributions from the library are normal. My guess is it would be skewed right. You think about that? There's a lot, because libraries tend to be in like dense parts of the population part of the city. You have a lot of people living near the library. And then you got those few scattered people that are like far away. And that would be a skewed right distribution. Does that make sense? There'd be some outliers that are far, but you're not going to have outliers that are close. Does that make sense? So my guess is they're not normal, which right away it's probably a bad thing. Okay. The standard deviations are equal. I have no idea whether the standard deviations of distance from the library from these 4 races are the same. I have no clue, but who knows? So again, I'm giving you a heads up. ANOVA is a lot more, there's a lot more depth to it than what we're going to get into today, because we can't go through these assumptions and actually test them. We can just like say we're assuming. Okay, what else do we have to assume?
The samples are independent.
Yeah, so samples are independent.
In this case, like, I mean, what if all these people live in the same area? Would they still be considered independent?
Yeah, this is one of those where it's almost certainly independent. This one, these would almost certainly be independent. The only way it might be dependent is like if you did something silly and you said, well, we're going to look at couples that are interraced couples. And we're going to look at the, you know, we're going to ask the husbands and wives each of, you know, how far they live, and that would be completely dependent. Does that make sense? It would actually, it's actually hard to come up with dependent samples for something like this. So assumption number 4 is the easiest one to say, yeah, I think that one's good. Does that make sense? And to make it work. The others are tough. Unbiased is always hard. Normal, I doubt it. Given the fact that we have some small sample sizes, I doubt it. Do you see that? Standard deviation, I have no clue. But number 4 is probably not an issue. Does that make sense? Okay, then we go to number 5.
The samples need to be collected consistently.
Yeah. The sampling must be consistent. For all 4 race. Okay, so that means that when we did the survey, we didn't like talk to Hispanic people differently than we talked to Black people. Okay, that's also probably not that hard to do, to make that consistent, but you just have to make sure it's okay. Any questions on that? One thing you might want to, like the big on this one probably is that you just got to make sure that when you're asking Hispanic people that you speak Spanish, that you understand Spanish, so that they don't understand English, you can ask them in Spanish, and that way you're not biasing towards only those that are, you know, one type. So that would really be the main thing there. So you just got to make sure sampling is consistent. Any questions on this particular example's assumptions? Okay, so then the next, and this is kind of the biggie, is show the details of the ANOVA test and state your conclusions in the context of the study. So at this point, if you don't know what H0 means, then you're not passing this class. Because we've been doing this for like a month now. So the null hypothesis. And now we got to say, what do we put in? What symbols do we put in?
Mu 1.
Yeah, so the hardest part is getting it typed in. Insert equation, let me insert. There we go, now it'll let me. I don't know why it was being mean. So mu sub, and again, we're looking at white, black, Hispanic, other. So the good news is they all start with a different letter. So let's call it mu sub W equals, and then let me in there. There it is. Mu sub B equals mu sub H equals mu sub O. So the population mean distance from the library for whites is the same as the population mean distance from the library for blacks, which is the same population mean distance from the library for Hispanics, which is the same population mean distance from the library for people of other races. Any questions on that? Okay, and then H1, that one, it's a lot easier to do without symbols. So that one we could say at least 2 of the races have different population mean distance from the library.
Okay, here's the question I have about that's related to project 2, which is why would you use population mean distance there?
Well, in not in H1, both of those I use population mean distance, right?
Oh, yeah, okay, yeah, this is for the hypothesis. Okay.
Yeah, because see the mu?
Mhm.
The mu represents the population mean difference. The sub B means for Black people. So just for ANOVA, because when I used to do H1 in symbols, it was a complete mess. And I just couldn't get everyone to get it. So I gave up. And I don't give up too often, but I gave up on that one. So I decided I better do that one in sentence, as a sentence.
Well, will we ever see H1 in symbols in articles and stuff like that?
Probably not articles unless you're reading a math article. And then you'll see it in symbols. But typically in articles like this guy, you won't see it in symbols. Okay. But if you're reading a math journal where they're doing ANOVA, then you'll see the symbols. But since I don't think any of you are math majors, right? You probably won't ever see it. Okay, any questions on this? Okay, name of the test. That should be easy. What's it called?
ANOVA.
Yep, ANOVA. Okay, and by the way, all the letters are capitalized because each letter stands for something. Although if I had a choice, N wouldn't be capital and A wouldn't be capital because AN means analysis and VA means variance, but that's the way everyone writes it. So that's the name of the test. Okay, what do you think a good level of significance would be for this particular example?
5%.
Yeah, 5% or 0.05. So alpha. I know, there. Equals 0.05. Okay, because this is social science, right? Distance from the library from different races, that's about as social science as it gets, right? And social sciences pretty much always use 0.05. Any questions on level of significance? Okay, how do you think I'm going to get a p-value? You should
Using
know
the
by now.
calculator.
Yeah, we can go to the calculator. The good news is I told you today's the last day of class. So you should know, it should be really obvious which calculator to use.
Last one.
Yeah, last one, which happens to be called ANOVA. Okay, I tried to make it easy. And by the way, I want to remind you, if you have any suggestions for the calculator, let me know. And if I can, I'll make the adjustment. But so far, at least the naming, everyone's happy with. Okay, so the way I put it is data 1, data 2, data 3, data 4, data 5, 6, 7, up to 8. By the way, if you had to do it with, let's say we were doing the test to find out if there was a difference in the mean income by state, then you can't use this calculator because this only allows you to do up to 8. So what would you use instead? You all know it.
Math.
The spreadsheet. Yeah, so you use a spreadsheet, what we use for project, project 1 and 2. And there's a little ANOVA tab. So I made sure it does have everything, by the way, everything we do. And that allows, since it's a spreadsheet, you can go as far as you want. You could do 50 if you really wanted to, but I wouldn't ever test you on like 50 of them because it would take forever to just type them all out. Do you agree? So instead, we're going to do just ours. Let's go to our data. So we have 15, 4, 11, 9, 3, 2. So 15, 4, 11, 9, 3, 2. Commas in between. We have 12, 1, 6, 6. Commas in between. Any questions? We have 9, 17, 5, 14, 7, 1. And then we have 18, 11, 2, 8. Any questions on using this calculator? Okay, there's not much to do here. I want to let you know a couple things. One is it's a lot like chi-squared. There's no such thing as a left tail or a right tail test with ANOVA. It is just a not equal to, basically. It's just ANOVA. So you don't have to even deal with that stuff. That's why all there is a button that says calculate. The test statistic, and this is new, is something called the F distribution. Okay, I didn't name it, by the way. That's what they call it. I can't get into the mathematics behind it because it's way too hard for this class, but there's some very deep mathematics behind the F distribution. And it's just like we've had a lot of different test statistics. I noticed, by the way, and you don't want to make that mistake again, on the exam that you took last week, a lot of you, when I asked for the test statistic for regression analysis, gave me the correlation instead of T. So when you have regression, the test statistic is a T, student's t-test, not an R. R is the correlation. When you have ANOVA, the test statistic is F. And that's a new formula that is too hard to get into. But all I want you to know is another letter. Sound good? Okay. So our test statistic, about 0.3339. So let's do that.
Is that equivalent to like a Z-score? So that would be like pretty low, 0.3339.
One more time.
Is that F score kind of like a Z-score? Like,
Kind of, yeah. It's a lot more complicated. That's why I can't get into it.
okay, so
But yeah, it's
okay.
similar. A very big F is going to have a small p. And
Okay.
here, notice we have a small f, and we had a big P.
Okay.
Yeah. So it's the same idea. There's a curve. In fact, if you want, I can show you the curve. So then you can actually see the test statistics. I think I did this. It's been a while. I can do it this way. Thought I put it in. Sorry if I don't have it immediately. There we go. So here's the F distribution. Does it look like a normal distribution? No, it doesn't. It turns out there's two sets of degrees of freedom. It has to do with sample size stuff. I'm not going to get into it. And if the numerator degrees of freedom gets bigger, it's a little less skewed to the right, but it's still skewed to the right. We can let the denominator degrees of freedom get bigger. And it looks like this. So there's our F distribution. Does that make sense? And you'll notice if you're, if F is bigger than 2, that area to the right is pretty small. You see that?
I
So it's
didn't
pretty
see any
similar.
changes. Is there supposed to be changes on this thing?
You didn't see it change?
No.
Here.
Oh, I see. Okay, it's very slight.
Yeah. Yeah. And the math is way too intense to even like start talking about it. So you need to be a graduate student in math to truly understand it. It's very intense. So my guess is, Braulio, you've never dealt with the math of F, right? Yeah, I didn't think so. It's a lot of, just not going there. Sound good? But you could look at a picture. That's not too hard to see, is it? Okay, so that's your F. Okay, and again, it's a little like the Z, is it? If you're bigger than 2, then the area is small. Okay, but our p-value was about 0.8. Sound good? So if the p-value is 0.8, you better all know what to do with actually any level of significance, but we got 0.05 as our level of significance. What's the first few words? We've been doing this for a month now.
With, or there,
Not with,
there.
there. Is. There's a few choices here. Yeah, statistically. Okay, and now comes the word that's different if the p-value is big versus small. And what is it? With a p-value of 0.8, big p-value. Yeah, insignificant. There's statistically insignificant evidence to make a conclusion. So far, nothing is different in terms of what I've typed. Do you agree? Whether, and then the easiest way to do it
Any of the population mean? No.
is copy and paste H1. And then uncapitalize the first letter.
Hey,
At
how
least
come we don't
2
use-
of the races have different population mean distances from the nearest library.
Why don't we use the word prove?
Okay, so prove is dangerous. So the word prove means you are 100% certain. Because proof is a math word, right? For example, you probably at one point, I don't know if you remember it, learned the quadratic formula. If you have ax squared plus bx plus c equals 0, then x is equal to negative b plus or minus square root of b squared minus 4c all over 2a. Okay, if you don't remember, that's okay. That is proven. Got it? There is no question. It is just correct. But when you do statistics, even if you have a small p-value, you have not proven anything, because you still could be wrong, because still there is a chance of a type 1 error. Do you see that? So when we're doing statistics, never use prove, because we never prove anything. All we do is provide evidence for something. Do you see the difference? So that's the reason. Yeah, prove is a dangerous word in statistics. Okay, the only thing you prove is the central limit theorem. Well, you don't prove it, but I had to when I was a graduate student. But the point is that you don't prove any result in terms of running statistics, inferential statistics. Does that make some sense? Yeah, because prove means there is 0 chance of an error. And that never happens with statistics. Does that make total sense? Yes, that's an important piece. So if I took off points, then hopefully you remembered it so that you'll never use it again. Okay, not just for this class, but in your upper division coursework. Is that the word proof is not okay for anything that's done using sampling. Okay. Any questions at all on this ANOVA example? Okay, by the way, if the p-value had been, say, 0.002 or something, what would change in this conclusion? Not much,
There would be, you would say there is statistically significant evidence.
right? You get rid of the IN and you'd say statistically significant evidence. To make a conclusion, instead of whether, you just say that. Okay, at least two of the races have different population mean distances from the nearest library. I want to let you know something, and this was true with chi-squared also, is that if there is statistically significant evidence that at least two are different, let's say we found that out, does this ANOVA test tell us which two? No. Could that be found?
Probably, but not with the ANOVA test.
Yeah, the answer is yes, and you need to take upper division statistics, which is kind of like what today is all about, is saying there's more statistics you could do. Okay, and there's multiple tests that will check which ones are different, but we can't do it in an elementary stats class. Any questions on that? So I want you to know that ANOVA does not tell you which ones are different. It just tells you that we have two that are different or we don't have evidence to know. Any questions at all on ANOVA? Okay, so what do I still have to do? Here's the hint, I forgot it once.
Oh, the word.
The secret word. Okay, and the secret word for this week is two words, actually. So it's a trick question in a way, and it's thank you. And I want to thank you for, haven't had any like aggressive bad people doing bad things to each other or anything like that. So that's a good thing. You've done your best. Most of you have worked really hard, and hopefully it'll all go well. So I want to thank you for being professional students. That's what I hope, having courtesy and all that kind of stuff. So thank you is the secret word for this week. And it's the last secret word of the entire course. And we've now seen the very last new material in statistics for elementary statistics. So what I want to do now is talk about project 2. Okay, and not go over the requirements because I did that a few weeks ago, if you remember. Hope you remember. So I know that some of you have already sent me, which is great. Actually, this class is nice in that a lot of you are like really have your heads up and working hard and getting things, not waiting until the last minute, because that makes a huge difference. So I've already gotten more than half the classes sent me their projects, okay, for their rough draft, which is really nice. But those who haven't yet, you have until Thursday morning. And I want to let you know that whether you that I read it once, that's the rule. So I read through the whole project once, but I answer questions whenever. But don't just say, the question I won't answer is, well, read it and tell me what's wrong now, because that's reading it twice. So just so you know, that's the only thing, that's the one thing I won't do, because I only read it once. But I'll be happy to answer questions. I have my regular office hours too. And Braulio, you have a bunch of hours this week?
Yeah, I'll be here. Yes, I'll be here from until 6 p.m. today, and then 3 to 7 and 1 to 6.
Yeah, so Braulio has a whole lot more hours than I do, because I teach a whole lot. I teach multiple classes, and I can only do so much per hour. So Braulio is definitely the go-to person in terms of having lots of hours, whereas I have an hour a day up until Friday. Okay, and again, don't expect to send me something on Sunday night at 10 o'clock and hope I'll get back to you before it's due, because I'm asleep. And so just let you know that that's you don't want to wait till the last minute, because that's a big deal. There's also the project 2 discussion board, which I'll be checking, and be happy to answer. And but you can talk to us also. things that are important that, you know, you want to kind of focus on, make sure that everything is done in such a way that you are talking about what decisions the client should make for each individual item that you're looking at. And something that a lot of people have trouble with for some reason, and I'm not sure what else I can do to tell you have to do it. And that is, you should look at the lower bound of the confidence interval and just the lower bound itself. Comment on that. And if the lower bound is hit, then what would that do in terms of a decision the client would make?
What
And
did you
then
say?
say,
Lower
if the upper bound is hit, what would that do? Does that make
What do you
sense?
mean by-
Oh, in other words, if the population mean really was the lower bound,
Uh-huh.
and that's what your client thought, went with that assumption,
Oh, okay.
then what detail, what work would the client do based on that lower bound?
Can I ask you about that
Mhm,
a little bit? Because you gave us that advice.
mhm.
And so
Right, and it's
then,
not just you, by the way, the whole class, basically.
okay, so we were comparing Home Depot with Lowe's.
Mhm,
And, you know, we had a confidence interval of like -$2 to like $4, something like that,
Mhm.
right?
Mhm.
And it just seemed like, and the mean was like $25,
Mhm.
right? So I think it was -66 cents or something. And so I just felt like it was such a nominal amount, both the lower bound and the upper bound, that it was, I mean, we ended up saying like, okay, if it was the lower bound, the client wouldn't make any differentiation between the two stores. But if it was like a $4 or a $5 difference in the upper bound and they were buying in bulk, maybe they would like choose to shop at Lowe's, something like
Right. So if the money is not that much of it, you know, if it's 66 cents,
that. Mhm.
then if let's say Lowe's was closer, they'd shop at Lowe's, if you know what I mean.
Right.
But if they were equal, so if Lowe's and Home Depot were like both across the street,
Mhm.
might as well go to
Oh,
the one
okay.
that's cheaper. Do you see?
I guess so,
Only if
but
they were like really the same. Do you know what I mean?
okay, yeah, I see what you're saying. Okay, but
Whereas
how about this?
if
Sometimes
Home Depot is
it's home,
cheaper, then you go to Home Depot if they were both across the street.
but what if our confidence level was negative at the lower bound and positive at the upper bound?
Right, right. So that's the thing, is that's why you interpret the lower and upper bound individually first.
Okay,
Okay, so
okay,
that's
I
the
got
first
you.
thing. You interpret them individually first. Okay, and as you said, if there was any inconvenience, then they go to whatever is the more convenient one.
Mhm.
Do you see that?
Yeah,
But if there
okay.
was no inconvenience at all on deciding one or another, they might as well go for the cheaper one, right? Wouldn't you?
I guess so. Okay,
Right?
yeah.
Yeah. Hey, if it's a little cheaper, you go for it. Right?
And
If there's nothing other involved, no other
do you
issues
want that
involved, you go
for
for the cheap one.
all three
But
confidence intervals?
huh?
Do you want that for all three confidence intervals?
No. That's why I told you, you're looking at all three, and then based on the pros and cons of each of the three, you choose one.
To do the full analysis.
And then you're going to use that one to do the full analysis in the lower and upper bound. Does that make sense?
Okay, I gotcha.
Yeah. So you choose one, and then all the rest of it is based on the one that you chose.
Okay.
Does that make sense?
Mhm.
So like a paragraph on which one you chose, and then a few paragraphs on the one that you chose and what decisions you made based on the lower bound, the upper bound, the fact that zero is in the middle, that it might just
Okay.
be they're exactly the same. That's possible. It's not likely, by the way, because exactly zero is pretty much can't happen. It might be off by 1/millionth of a cent, but you know, the point is that exactly the same won't happen, but if they were really spread out, then the lower bound makes a huge difference, right? And the upper bound, right? If you save $1,000, you know, with the lower bound, if that happened, that would make a big deal. Do you see that?
Mhm.
But if you save $1, it may not matter, and say a, a couple $100 purchase or something. Does that
Okay.
make some sense?
Yeah, it does. Thanks. I think I
Yeah.
got it.
Yeah.
Um,
And then if the bounds are close enough to each other that it really isn't going to matter in the decision that the client is going to make, then and especially at the 99%, then your standard deviation standard error is definitely small enough. Do you see that?
yeah.
But if the decisions
Oh.
would be made differently, or if you had to go to the 95 instead of the 99 because you needed to make those decisions the same, then a standard error would be helpful. A smaller standard error would be helpful. Do you see how that works?
I do. I mean, in our report, we said we went with the 95 confidence interval, but then we felt like our standard error was small enough. Are you saying that those two things are not, they're like kind of mutually exclusive? If we're not going for the 99%?
It was small
confidence,
enough for 95, but not a 99.
okay,
Do you see?
yeah,
So if you wanted the 99, then you say, well, how big a sample size would you need to make it small enough? Do you see?
I see. And that's where the math comes in. Sigma of x bar over square root of n, right?
Right. So if you need your standard error to be like 2 times less, then you need 4 times the number of samples.
Okay, I gotcha.
Do you see that?
Yeah.
Sample
okay.
size would have to be 4 times, because remember, it's the square root of the number.
Okay.
Where if it was just 1 time less, about 1 time, let's say, 1.3 times less, then you can do that and do the square root of that and all that, or that
Okay.
squared. Do you see?
Yeah, I think I got every single thing. I mean, I'm trying to understand your suggestions and where my conceptual misunderstandings are.
Mhm. And I want to
Okay.
let you know, when I give, and not just for you, but everyone, when I give the suggestions, I only give suggestions for improvement. I don't talk about what's great. So just because I gave a lot of suggestions does not mean you have a bad paper.
I get
Okay.
that.
Yeah. So just to note that. Don't feel bad because I gave suggestions. Everyone gets suggestions. And in fact, I try to give similar number of suggestions. And sometimes the suggestions are like huge things. Sometimes if I give minor suggestions, that means you have a really good paper.
Well, last time we didn't even have the standard deviation paragraph at
That was
all.
that was a biggie.
That was a
Right.
big miss.
That's a big suggestion. Yeah.
Yes. I think I'm all set. I'm curious why you enjoy teaching elementary statistics after getting a PhD in this field.
Well, remember, I'm at a community college. That's all we've got.
Uh-huh. Would you be
Um,
teaching upper division if you could?
See, I taught at a university, but the problem with it, if you want to know me personally, the main focus at a university is research and not teaching.
Hmm.
And I like teaching. And I wanted my main focus to be teaching, and community colleges, the main focus is teaching.
Oh, I see. Okay.
So that's why I'm at a community college. And I love living in the mountains, so that's why I'm in the mountains too. And there's only one college in California in the mountains, and that's this one.
Okay.
Okay, and I grew up in the mountains, so that's another piece. That's a whole different thing. And why do I like teaching statistics? Because statistics is the most useful of all mathematics. And hopefully, at this point, because now we're done, you agree that there's a lot of use to statistics.
Yeah, it's nice. It's it's been an interesting interface to see math really come to life.
Yeah. Whereas if you take an algebra class, it's really hard to see like a whole lot of uses for most of the stuff you're doing. Does that make sense?
Yeah.
And there are uses, but the stats, it's like I just go to the news and find something. Like with COVID, I mean, if you don't know what COVID is, you're like asleep. And I was able to find something that related to what we're doing. You know what I mean? And I can always do that, and it's not just because we're in times of COVID. There's always statistics done on anything that's going on. Does that make sense?
Yeah, I do. I appreciate your class a great deal. I haven't really taken a math class in like 20 years, and I actually didn't pass algebra. but somehow I managed. So
Yeah, but
anyway,
algebra is very different than statistics, isn't it?
well, I knew that intermediate algebra was a prerequisite for this course.
It used to
I-
be. It isn't anymore.
Okay, I convinced them to let me take it anyways, and I had a tutor ready just in case I could not keep up.
Yeah, his name is Braulio.
Gosh, yeah, Braulio's been pretty great. But yeah, anyways, but I've really enjoyed this. I didn't think I would enjoy it as much as I have.
Well, good, good, good. And I want to remind you all, if you ever have stats questions, as long as you're a student in anywhere, could be in graduate school, for example, showing me your dissertation, having me look at it. I'll be happy to answer any statistics questions you have. No problem. And if you are out of school and it's for your business, I'll still answer any statistics questions you have, but then I want you to donate to a scholarship at our college. So I do want you to pay. You don't pay me, but I want you to give back to the community because then you're a business person. That's different. And I let it be up to you on how much you want to donate. But the point is that I believe in helping out students if we can. But if you're a student, then of course, I don't expect you to donate to scholarship because you're dealing with trying to live and make it through. But once you're making money, that's different, especially if it's your business. And I've had several thousands of dollars actually donated from working with people, with businesses. And the great thing is stats is everywhere, including businesses. So I'm always happy to help. And even if I'm retired, which will be, several years from now, but my email hopefully will stay the same. Okay. Eventually I won't be here, but I'll be dead, then it won't matter. But the point is I'm here to help out, and because stats isn't going to go away, even though you're in a week from tomorrow you'll have finished, maybe a week from today you'll have finished your last thing you have to do for the class. Afterwards, you're going to have stuff that you have to do for stats, not for this class, but stats is everywhere. So that's just a note, and so I'm happy to help out because it definitely is used. Okay, and I've used it for all kinds of things.
Okay, I'm gonna head out. Thanks again, Larry. And
Okay, thank you. And just note, I'll be checking my email. I'll be checking the discussion boards. I'll be online for my office hours. Always happy to answer any questions you have during the class.
Yeah, same here. If you got your notes back from Larry, feel free to send them to me and I can look over them. But yeah, thank you. Goodbye, everyone.
Okay, I think I'm going to stop the recording. It's hidden. There it is.